go. Lasst uns einsteigen in das Interview. Viel Spaß. Now we see her. Okay, sorry. This is the young lady here. Let me go back. This is actually the basic figure. Yeah. And from this figure, all the copies have been made. If it was porcelain, if it was... this is the guy who made it. Yeah. Walter Schott. He is a sculptor. And he did this statue, actually, I think for Berlin. It was shown in Berlin. And here she is, standing in Köpenick, yeah, because she was stolen in 1950, and they put her back, I think, in the early 80s. She was brought back in the 90s and to her old form, because she was stolen, yeah. And I was so amazed by this form, by this statue, that I choose this as my favorite object for the scanning process with your app. So, cool. So here we have the object, the ready-made object, yeah. Mm-hmm. And I wanted to show it in your app already. Yeah, this is the final process that has been done. And here I show actually the way I do it. Yeah, and maybe we can talk a bit about it. And these both pictures are running now parallel. So when I start to scan here, this will also be shown here, because I recorded both. Yeah, I recorded your scanning process from your app, as well as I recorded myself outside. So maybe you'd like to explain a bit what we're going to see.
So, okay, you probably know the photogrammetry process, where you capture many photos, and after that you use a computer to process it all, and to find out in the end, after a few hours of processing, that it didn't work because there was bad lightning or anything.
Right.
What's different in my app is that it's using this AR motion tracking, which get the device position. Mm-hmm. And calculating the device position from the photogrammetry, that's the most time expensive thing. Mm-hmm. And because of AR, I can do it in real time. Mm-hmm. Mm-hmm. So that it's also possible in real time to do the reconstruction, mm-hmm. and directly show the feedback to the user.
Which is
mm-hmm. To make visible what's already scanned, and to show what's needed to be scanned, what's mm-hmm. missing.
And it's working fabulous. It's just as you can see, the statue was scanned very good, and I'm so proud of it, because it's an object that worked fine with the lightning, with everything, you know, and now it's here. Who can use that? Did you ever think about that? Who's going to use this app?
A big impact has it in architecture.
Yeah, definitely.
Because you can scan a flat, and then you have a floor plan, and you can measure there everything. You can put their furniture to test if everything fits. That's a really powerful usage. Mm-hmm. And yeah, I get many use cases from my users. Uh-huh. I know there is happening a lot of scanning in underground.
Uh-huh. Okay.
In underground, you cannot really, there are no maps, and you can hardly say how many meters did you walk, how many degrees you turn, and so on.
Okay.
And simply people scan caves or catacombs, anything, mm-hmm. and then this model is basically a 3D map.
Wow. That's interesting.
It's even more amazing that you can then upload it into Sketchfab, mm-hmm. open it in a VR headset, mm-hmm. and see it in virtual reality.
It's for me still a wonder. You know, I still consider this as a wonder. It's like rocket science for me, and it's bringing us to places where we haven't been, and also to places where we might not should have been. Yeah. but it raises the curiosity, and this is one very important element, I think, in this, that curiosity. It brings us back to things that I wouldn't have never found the statue of the Kugelspielerin in Köpenick without your app. You know, I was not interested in this statue, but now I have something going on with this girl. You know, with this statue, with this form, simply because of your app, and I could go into the depth of a bronze statue. Yeah, but I think game developers, 3D animators, props and interior design creators, location scouts, architects, as you said, restorers, event managers, and so many more are going to use this kind of app. And I hope that you already got your feedbacks from those kind of jobs.
Yeah,
from those kind. Cool. Tell me.
It's the thing is, mostly at the moment, only geeks are interested in technology, because it's new. It didn't reach the mainstream. But I have contact with some teenagers who simply scanned their rooms, and they put it in games like Counter-Strike, if you know.
Wow, Counter-Strike.
Yeah,
Really?
I didn't see it, but they told me.
That sounds great. You should maybe somebody can take a video from that and you send me. I want to implement that also on my thing, because I think it's amazing to play Counter-Strike in your room. Like this is crazy, and that's cool in the same way. You know, it's not crazy like destruction. It's crazy. It's like it brings us to new places in our heads. You know, it's a very philosophical thing. What's going on here for me? Yeah.
Yeah.
It's cool.
And the thing is, where it get the most of the response are the universities, the people who are doing research, and they need the data from the device. And that's why I made, let's say, a small demo code, how to open the capture data in some or convert it into different formats, so they can work with it. And yeah, they are doing interesting things like segmentation. So if you have a scene, there are many things. This segmentation can say, this is chair, this is table, and they replace this, let's say, raw data, which the scans are not perfectly clean. They replace it with high quality 3D models.
They work on the polygons as long as they suddenly are straight. Like if there's a curve in the scan, they just put it in Blender, they open it up, they ease it, they smooth it, and then it looks great.
That's a bit another approach. What are they doing? They are detecting that these polygons represents a table. And then they delete this table from the scan, and they put their table model with a beautiful texture, and basically make the model really smooth, because then you have high quality models, and they can detect mirrors. So they replace, the scanner doesn't work well with mirrors, because it always scans the data behind the mirror, which is wrong. But they can detect it, and they put into 3D model a mirror, and they say, okay, this glass has a big reflectivity, and based on that, you then see the reconstructed scene from them, and they have their mirror which reflects. It's not the mirror which is showing the things scanned behind.
So, but they're doing this in this post-procession or this post-production work they do in a 3D environment, like in a program, right? Like, I don't know, like Adobe, or I don't know what is the preferred software to work with this?
They are mostly not doing it in a program you would know. They are using Python, which is for researchers the most used language programming. And yeah, they are using artificial intelligence, machine learning, and yeah, basically they get the data, use own program in Python, convert the data, and then they open it in a program, Blender, MeshLab, or anything, Adobe.
Wow.